Hey guys, we hope you had a great Halloween weekend and had lots of fun. Today we're going to continue talking about input and output tables, and you may want to go back and watch the videos from Thursday to refresh your memory about what we talked about then. Today we're going to be focusing on looking at a number pattern and the position of those numbers in a pattern and how it relates to the rule or the function of that pattern. Okay, so it's similar to what we did on Thursday, but just with a little bit added extra. So what we're going to do is we're going to start by looking at this question, and I'm going to walk you through. Okay, so a number pattern begins with these values, 6, 12, 18, and 24. Which number table correctly represents the relationship between the position of the number and the pattern? So the first thing we need to look at is the word position. Okay, position. That's where the number is in the pattern. So the number is, it can be, this is the first position, this is the second position, this is the third, and this is the fourth. And we want to represent how what is in each position relates to where it is. So if it's in position 1, how does it relate to position 1? If it's in position 2, how does it relate to position 2? So the first thing you need to look for when it asks about the position of a number is look for the tables that don't show position 1, 2, 3, and 4, because position is always going to be first, second, third, or fourth in this list of numbers. So here we have, this is position 6, 12, 18, 24. That's saying the 6 is in the 6th position and the 12th is in the 12th. That's not true. In the list here, we have position 1, 2, 3, and 4. So we can go ahead and eliminate these two answer choices. Okay. Now we need to talk about how what is in the pattern relates to where it is. Okay. So it says this pattern begins with these values. So these are your values. Okay. So when looking at the answers, we need to also look at the values. Okay. So these values say 7, 8, 9, and 10, which we don't see here. Here we see 6, 12, 18, and 24. And so by process of elimination, this is our answer, but I'm going to explain why this answer works. Okay, so we have position 1, we have a 6. Think of the position as your input and the value as your output. What's going on to that 1? Well, over here we did plus 6 equals 7. Well, that's not what's in that position. Okay, here we did 1 times 6 equals 6, which is true. Now remember, this is a bad iPad or a function table. It only does one function or one rule. So we need to see if the expression, the position of the number times 6 equals the value. So does 1 times 6 equal 6? Yes. Does 2 times 6 equal 12? Yes. Does 3 times 6 equal 18? Yes. And does 4 times 6 equal 24? Yes. So again, what you're looking for, you want to see that the position says 1, 2, 3, or 4, and so on and so forth, and the values are listed, and you're just really just finding this part right here, okay, to make sure the rule is the same and it works for every position and every value that's coming out, okay? So now let's do a problem together. Okay, so here we have a number pattern that begins with these values. Create a table that correctly corresponds or represents the relationship between the position of a number in the problem and the value. So we're going to start by listing our positions. So we have 1, 2, 3, 4, and 5. So our positions are 1, 2, 3, 4, and 5. And our values are what's in the list, 7, 13, 19, 25, 31. 7, 13, 19, 25, 31. So we already have most of our table complete just by organizing the positions and the values. Now we're going to see how we got from 1 to 7. 1 to 7. Okay, so what we're going to do is we're going to think, how can I get from 1 to 7? Well, I can add 6, but that wouldn't work here. I could times 7, but that wouldn't work here. So if that doesn't work, you may have to have what we call like a double expression or a double pattern. So we need to think we can multiply and then add something. Okay, so let's try position times 6. 1 times 6 is 6, right? To get to 7, we'd have to add 1. Okay, so let's see if position times 6 plus 1 would give us our value. So here's our position. We could do times 6 plus 1. So 2 times 6 is 12 plus 1 is 13. That works. Okay, then we could try 3 times 6 is 18 plus 1 is 19. That works. 4 times 6 is 24 plus 1 is 25. That works. 5 times 6 is 30 plus 1 is 31. That works. Now, you're not going to see an expression like this a lot of the time, but just know that it's possible for you to, you won't necessarily always have to create this, but if you saw it in a table, just know how to read it, okay? And as long as you're doing the same thing to each position, we did, even though we did 2 things, it was still the same thing. We times it by 6, then added 1. Times by 6 and added 1. Okay, and remember that word we used last time, I called trial and error. So this would have taken lots of trial and error. Okay, now let's go over your work for today. It's not going to look quite, it's going to look like this, but you're not going to have a double rule or expression to come up with. Okay, so let's talk about your work for today. So it's called Build a Table. So if you come here and click on the Build a Table link, you'll open up this assignment. It's a Google Slides assignment that has each text box you're going to have to fill in information. So I'm going to walk you through a lot of this. All right, so build a table that shows the relationship between dogs and legs. So the first thing you're going to type up here is dogs. Okay, this is our position. And then legs is going to be our value. Okay, so we're going to start with our dogs. We're going to start with 1 dog, 2, 3, 4, 5, and 6 dogs. And our values are going to be, okay, how many legs does 1 dog have? Well, 1 dog has 4, 2 dogs have 8, 3 dogs have 12, 4 dogs have 16, 5 dogs have 20, and 6 dogs have 24. So then you're going to come up with the relationship or the expression or the rule from the number of dogs to legs. So 1 dog has 4 legs, so that's 1 times 4. 2 dogs have 8 legs, so that's 2 times 4. 3 dogs have 12 legs, so that's 3 times 4. You see, we're doing times 4 is our ruler to our position. Okay, 4 dogs has 16 legs, so 4 times 4. And then 5 dogs is 5 times 4. 6 dogs is 6 times 4. So our rule is we're multiplying the number of dogs by 4. Okay, so after you fill in the table, you're going to come answer all these questions. In a complete sentence, describe the numerical relationship between dogs and legs. Now, you can't just tell me times 4 because I don't know what you're multiplying by 4. So the numerical expression is dogs times, or number of dogs times 4 equals number of legs. You have to write that whole thing, not just times 4. Tell me what you're multiplying and what you're getting out of it. Okay? Then, how many legs would you count if the animal shelter counted 33 dogs? So it'd be like filling in 33 here, doing this numerical expression and getting legs. So you would do 33 times 4. Okay? And so I hope y'all are going to do this on your own, on your paper. And so 33 times 4, that's how you would come up with that answer. So finish that work and come up with that answer. Then how many dogs would you have if you had 48 legs? So in this case, we're having 48 legs, so we're working backwards. So if I worked backwards, I'd be doing, 48 divided by 4 to get an answer. Again, do that work on your own. Okay? So, again, you're going to fill in the table, answer these questions. When it asks for the numerical relationship, you use words and what you're doing to get your values, and then answer these questions. Okay, each one is very similar, but pay attention to what it's asking for. So in this one is asking about grasshoppers. Have 3 parts. Okay, they want to know the relationship between grasshoppers and antenna. So you need to know how many antenna a grasshopper has. It has 2. So this column would be labeled grasshopper. This column would be labeled antenna. And you would just do the same thing as you did with the dogs. You 1, 2, 3, 4, 5, 6 grasshoppers, and how many antenna for each? Fill in the numerical relationship. Then read each question carefully. Again, this first one's going to look a lot like this one, okay, where you're having to write the expression, except this, in this case, you're talking about grasshoppers and antenna. Then this one talks a lot about cockroaches, and it's asking to build a relationship about cockroaches and their legs. So this would say cockroaches, and this would say legs, just like the table for the dogs. And you have 2 questions about that, okay? And it says, in a complete sentence, describe the relationship between cockroaches and legs. That's basically like writing this. And the last one is about spiders, and again, about spiders and legs. Okay, so this would say spiders, and this would say legs, and you'd fill it in the same way you do here, except obviously you're not doing times 4, you're going to do a different number there. Okay, but that's how you do each of these parts. Okay, again, I did the whole first one for you, so you only have to do 3 on your own. All right, and please, as always, upload any scratch paper you use to show any of this work down here, so we can just see your thought process. All right, let us know if you have any questions about that. Y'all have a great rest of the week. See you later. Bye.